B and C. They both are going to be the exact same answer, but I'm going to solve one to show you guys why it works, and then the other one we'll talk about what you could just do instead of solving it. So we look at B. We're going to solve it the exact same way. Let's copy our first equation. 10 minus n is greater than or equal to a negative 2. Put our or in the middle. Now let's change our second equation. Keep the absolute value the same. 10 minus n. Flip our sign. Change our negative 2 to a positive 2. So, this is an or. Let's solve the first one. We have to subtract our 10, which gives us a negative n. It's less than or equal to negative 8. Okay, we can never have a negative variable. In order to get rid of a negative on a variable, we have to divide by a negative 1. Because we always assume there is a hidden 1 right there. So we divide by our negative 1. We have m. Now, since we divided by a negative, we have to flip our sign. And negative 8 divided by a negative 1 is a positive 8. Okay, put our or in the middle. Let's solve the other equation. We have to subtract our 10 again, which gives us a negative m is greater than or equal to a negative 12. Again, we have to divide by a negative 1 because we can never have a negative variable. Divide by a negative 1. We have m. We have to flip our sign because we divided by a negative. And negative 12 divided by a negative 1 is a positive 12. Okay, so here's our answer. And we've talked about our graphs before. We know an OR graph needs to be separate. They need to go apart from each other, right? So if we were to graph it, I'm going to put my 0 over here. We'll put our 8 here, and our 12 here. Let's graph the 12 first. Close circle on 12. And again, you can use the arrow. Since the variable's on the left side, the arrow is pointing left, so that means it goes left. Or we know our variable is less, and less is always left. And remember, these are two separate inequalities. So if they meet in the middle, they don't stop. They keep going, right? They keep going forever and ever and ever. So we're going to graph our 8 now. It's a closed circle on 8. Now our arrow is pointing right with our variable on the left, which means we can make it go right. Or our variable, which is m, is greater, which means it's always right. Okay, this is why we have a problem, right? We talked about this in 2.5 a little bit. If 8 is included, and it's going all the way to the right, all the way to infinity, and if 12 is included, going all the way to the left, all the way to infinity, that means every single answer is covered, right? So our answer is all real numbers. And again, I don't care if you want to put the infinite sign. You can. I'll know what you're talking about. Or you can write out all real numbers. Either or, I will accept. Again, if you have any questions on why that works, please email me or ask me in class. Okay, now let's look at this one. This is what you can do to identify that it's infinite solutions or all real numbers right away. So we look here. Again, we talked about an absolute value is always going to be positive, right? Every single time it's going to be positive. So anything we put in here is going to be positive, even if we put a negative number. If we put a negative 6 in there, the absolute value of a negative 6 is a positive 6. Because remember, we talked about absolute value is distance, and distance is always positive. So we see our sign. It's greater than or equal to. A positive number, that's what absolute value is. A positive number is greater than or equal to a negative number. So a positive number is always going to be bigger than a negative 3. And I know we have this equal to down here, and we know it will never be equal to a negative 3, but that greater than sign speaks mountains, right? So anything in here, a positive number, is greater than a negative 3. That's always going to happen. And since it's always going to happen, that means right away